Potassium triiodide was originally sold as Lugol solution, which was used to treat wounds and as an antiseptic. Nowadays, though, we use something called povidone iodine, which is iodine complex with a polymer. However, this name is a misnomer and it's actually povidone triiodide, which is complexed with a povidone, but we'll get into that later. All triiodide solutions are iodine and the iodide ion in equilibrated complex with triiodide, which is a black or brown colored solution. Potassium triiodide is also used in a laboratory setting as a reagent to identify starches such as beta-glucose chains and alpha-glucose helices such as ones seen in amylose starch coils. More specifically, triiodide identifies polysaccharides or long chains of sugars. When the polysaccharide interacts with the triiodide ion, they complex together and make a blue-black complex, commonly known as the black-blue or blue-black starch-iodine complex. The main difference between starch and cellulose is that starch or amylose uses an alpha-glucose bonding, whereas beta-glucose is the cellulose counterpart of the chain. And as you can see here, alpha-glucose makes a helix, while beta-glucose makes straight-chain polymers, or also called cellulose. Although iodine can be used as a supplement for thyroid hormone production or as an antiseptic, today we're going to be using it as a laboratory reagent to identify starch molecules, or cellulose. There are two main methods to make this triiodide reagent, and the first one is just simply diluting a solution of povidone iodine, which already has the triiodide complex in its polymer structure. To do this, I measure out 1 milliliter of povidone iodine in a 5 millimeter graduated cylinder. I pour the iodine into the 50 milliliters of distilled water, and the iodine quickly gets diluted into this reddish-brownish solution. I stir it with the back end of a fork, and once it's homogeneous, I test it in some starch solution. As the triiodide ion slips in between the starch coils of the amylose, it quickly forms a blue-black complex, or the starch complex that we saw earlier in the diagram, which is black. I begin to add more of the solution, and you can see that a black color begins to form inside a large beaker, which indicates the presence of starch. To show that this triiodide ion can also complex with cellulose fibers, I squirt some using a dropper on my backdrop, which is just made of printer paper. It quickly complexes the cellulose fibers, making this black color. I pour the rest of the iodine solution in the starch beaker, and I begin preparing the second demonstration, or preparation of the triiodide ion. And this is originally made by combining potassium iodide with solid iodine or elemental iodine. But here I'm just going to show a demonstration where I split apart the povidone iodine constituents and build up from the bottom. First, I measure out about 5 milliliters of povidone iodine solution and pour it into the 50 milliliter beaker. I then add some 1 mole of sodium hydroxide until an orange-yellowish color is obtained. The sodium hydroxide decomplexes the triiodide from the povidone polymer, and we obtain sodium iodide, sodium iodate, and some povidone derivatives, which settles at the bottom in larger solutions. I then add a dropper full of hydrochloric acid, which oxidizes the iodine from both the sodium iodate and sodium iodide into molecular iodine, sodium chloride, and water. I purposely add only 1 milliliter of the 20% hydrochloric acid because we don't want all of the iodine to be oxidized, because we want the formation of the triiodide complex. You can see as soon as I squirt in the 1 milliliter of hydrochloric acid, all of the iodate and iodide ions are oxidized into molecular iodine. However, there is still some residual iodide ions which complex with the molecular iodide to form this extremely dark orange, red, or brown solution. It seems like it's very similar to the povidone that we originally started with, and we're going to test it again in a large beaker with some starch. As you can see, adding just a little bit, the starch immediately complexes with the triiodide solution, forming this black liquid. It's important to note, though, that this is the standard procedure for making triiodide, and in a laboratory setting, molecular iodine would be combined with a solution of potassium iodide or sodium iodide, and it just makes more logical sense to use the original povidone triiodide complex because it already has the properties of the triiodide ion. However, this channel wouldn't be as exciting without experiments, and I decided just to build the triiodide ion from the ground up to show how it is made in laboratory settings or as a reagent. I transfer the rest of the sodium triiodide into a eyedropper bottle labeled potassium triiodide. However, this is just from an earlier batch and the label will be changed.